Namaste. Welcome to maths class. We were discussing about properties of determinants. We are solving problems. Let us continue. Next problem is using determinants. Or using properties of determinants. Show that one x square 1 x square 1 equal to 1 minus x cube whole square. See, given determinant 1 x square 1 x square 1 equal to 1 minus x cube whole square. We need to prove 1 minus x cube whole square. See, here we have 1, here we have x square. So, if you multiply by x to the second row, we will get x cube. So, R1 minus means we need 1 minus x cube. So, we can apply the operation here R1 minus x into R2. Let us apply R1. We are changing first row, that is R1 tends to R1 minus x into R2. See, now LHS equal to first row R1 minus x into R2, 1 minus x into x square is x cube, x minus x is 0, x square minus x into R2, x square minus x square, that is also 0. Only first row changing here, so second and third row remains as it is. So write 2 rows remain same, so x square 1 x square 1. Now here again we have x square, here we have x. So if you multiply by x square minus x square will be 0. Here 1 we have, here we have x square. If you multiply by x to the third row and subtract from the second row, we will get 1 minus x cube again. Okay, so apply here also R2 tends to, we are applying for second row, that is apply the operation R2 tends to second row, R2 tends to R2 minus x into R3, that is first row remains same, 1 minus x cube 0 0. What about second row? X square minus x into R3, that is x square minus x square, that is 0. 1 minus x into x square, 1 minus x cube, x minus 1 into x, that is 0. Third row as it is x square x square 1. Now from the first row we can take 1 minus x cube outside. From the second row also we can take 1 minus x cube outside. What will be remaining? 1 minus x cube take from the first row and again from the second row. So 1 minus x cube whole square. What is remaining? 1, 0, 0, 0, 1, 0, x, x square 1. Now expansion, expanding along, or here itself we can expand. Now expanding along first row, it can be written as R1. This is equal to 1 minus x cube whole square into 1 minus 0, that is 1. Other two values are 0. Therefore, this is equal to 1 minus x cube whole square. This is same as RHS. Okay, next problem. Show that a square plus 1 AB AC AB B square plus 1 BC CA CB C square plus 1 equal to 1 plus A square plus B square plus C square. See, what is LHS we have here? A square plus 1 AB AC AB B square plus 1 BC, third row CA CB C square plus 1. See, directly here there is no common term in any row or any column. We have a square plus 1, so we cannot take a common here. So directly we cannot take any common outside, and we cannot apply row R1 minus R2 like that, because we need to prove that 1 plus A square plus B square plus C square here. So here first multiply and divide by A, B and C. Here we have to divide by A, B, C, and we need to multiply by A, B, C. Here the term which we are dividing here, write that outside, that is 1 by A, B, C, and same term we need to multiply also, the value will not change. Okay, now which we are multiplying here, for that one multiply by A to the first row and multiply by B to the second row and multiply by C to the third row. Okay, multiply by A to the first row, multiply by B to the second row, multiply by C to the third row. What it becomes? A into A square plus 1, A into A is A square into B, here A square C, multiply by B to the second row, that is AB square, here B into B square plus 1, here B square C. Next multiply by C to the third row, C square A, C square B, C into C square plus 1. Now see, now we can take common from first row. A is common, here also A, Here also we have A. So take A from the first column. See second column B. Here we have B. Here also we have B. So take B from the second row and C. Second row also we have C. Third row C. So take C from the third row. What it becomes? From the first column taken A outside. From the second column taken B outside. From the third column take C outside. So 1 by ABC already we have. So 1 by ABC, then ABC is taken outside. What is remaining now? A square plus 1. From the first column A is outside. So what is remaining? B square, C square. From the second column, what is taken outside? B is taken outside. Write remaining values. What is remaining? A square, B square plus 1, C square. What about from the third column? From the third column C is taken outside. What is remaining? A square, B square, C square plus 1. Now ABC cancels here. We need to get 1 plus A square plus B square plus C square. See column wise, 1 plus A square plus B square plus C square. So which operation we can apply? Apply the operation. Let us add all the values, that is R1 plus R2 plus R3. Okay, R1 plus R2 plus R3. Here we are changing first row. What it becomes? 1 plus A square plus B square plus C square. Here again R1 plus R2 plus R3, A square plus B square plus 1 plus C square. It can be written as 1 plus A square plus B square plus C square. Similarly, third column, first, second and third row we need to add. Same here, 1 plus A square plus B square plus C square. Now, second and third row remains the same. B square plus 1, B square, C square, here C square plus 1. Now, 1 plus A square plus B square plus C square is common in the first row. Take it outside. 1 plus A square plus B square plus C square. What is remaining? 1, 1, 1 in the first row. Second and third row as it is. B square plus 1, B square. Third row, C square plus 1. Now, first row, it contains 1, 1, 1. So, which operation we can apply? Here, 1 minus 1 will be 0. 1 minus 1 will be 0. So we can apply the operation for second column and third column. That is C2 minus C1 and C3 minus C1. Let us apply that. Next, apply. For the second column, that is C2 tends to C2 minus C1, and for third column, that is C3 minus C1. What is that becomes now? Outside we have 1 plus a square plus b square plus c square. Now first column, second and third column changing. So first column remains same, 1 b square c square. Okay, now 1 minus 1, this is 0. See there, 1 plus b square minus b square, that is c2 minus c1. So b square cancels, remaining is 1. Next one, c square minus c square, that is 0. Then again second operation, c3 minus c1, that is 1 minus 1, 0. Then b square minus b square, that is 0. Last value, c square plus 1 minus c square. Okay, c square cancels, remaining is 1. Now this is equal to 1 plus a square plus b square plus c square into 1 into 1 minus 0, that means expansion along, expanding along the first row, that is R1. This is the term outside, 1 minus a square plus b square plus c square into 1 into 1 minus 0, other two values are 0. Okay, this is equal to 1 plus a square plus b square plus c square. This what we need to prove, that is same as RHS. Okay, this is equal to RHS. Now next problem. If x, y, z are different, and determinant, or it can be written as delta, equal to x, x square, 1 plus x cube, y square, 1 plus y cube, z square, 1 plus z cube, equal to 0. Then show that 1 plus x, y, z equal to 0. Here, if x, y, z are different, and that means x, y, z are not equal, and given that this determinant is 0, we have to show that 1 plus x, y, z is equal to 0. Now let us take delta. Given that delta equal to x square, 1 plus x cube, y square, 1 plus y cube, z z square 1 plus z cube. Okay, here if any row or any column contains sum of two or more terms, then that determinant can be expressed as sum of two or more determinants. Here, that is fifth property. Using that, split this determinant. That means it can be written as x square 1, y square 1, z square 1 plus second terms x square x cube, y square y cube, z square z cube. Now this is equal to x square 1, first one write as it is, y square 1, z square 1 plus, say the second determinant here, x square x cube, y square y cube, z square z cube. From the first row, what is common? X is common, take it outside. What is common in the second row? Y is common, and in the third row, z is common. Let us take into outside. Write the remaining. X is outside, so it becomes 1. Here x is outside, so remaining x. Next, x square. From the second row, 1 y square. From the third row, 1 z square. See, now compare these two determinants. Are they equal here? Here first column contains x, y, z, but here we have 1, 1, 1. Okay? Here x, y, z, here second column, but here first column. Here x square, y square, z square is in the second column. Here it is in the third column. So they are not equal, but the values are same. So we can make this as equal. Here, if you interchange any two columns or any two rows of the determinant, by the second property, the sign of the determinant changes. So, first one write as it is, y square 1, z square 1 plus, see, interchange here, we need to get x, y, z in the first column, just interchange second column and first column in the second determinant here. If you interchange, if we interchange any two columns or any two rows, the sign of the determinant changes. That means we need to multiply by minus 1 into x, y, z. Interchange here, x, y, z, 1, 1, 1. Third column as it is, x square, y square, z square. Okay? This is equal to first one, x square, y square, z square, 1, 1, 1 plus, see, again compare here, again they are not equal, so x square, y square, z square is in the second column, again interchange here, again if you interchange any two columns, when the sign of the determinant changes, that means we need to multiply by minus, So minus 1 into minus 1, minus 1 whole square. Here we interchanged first and second column. First and second column. Here we interchanging now second and third column, that is C2 interchange of C3. What it becomes? Here we need to interchange first column as it is, interchange x square, y square, z square. Here we have 1. Now minus 1 whole square, that is 1, x, y, z, x square, y square, z square, 1, 1, 1. Now these two determinants are equal, so we can take that outside. X square 1, y square 1, z square 1. That is outside. What is remaining here? This whole thing is outside, so remaining is only 1 plus here this term, this determinant is outside, so remaining is x, y, z. Now this is same as delta. See, now we need to apply the operation for this value. Here now the third column contains 1, 1, 1. So which operation we can apply here? We can apply 1 minus 1. This will be 0 and 1 minus 1 it becomes 0. So we can apply the operation for second column and third, or second row and third row. That means 1 plus xyz, that right as it is outside. We have to apply operation for determinant only. So here apply the operation 1 minus 1 0. That means for the second row we need to apply R2 tends to R2 minus R1, and apply for third row also. 1 minus 1 will be 0, so R3 minus R1. R3 minus R1. Now, what is that equal to? It will be only for the determinant. We are applying for R2 and R3. First row will be as it is, so write that same x square 1. Okay, what about second row? Y minus x, y square minus x square, 1 minus 1 0. Apply the operation for third row, z minus x. Here z square minus x square, z square minus x square. Here 1 minus 1, that is 0. Now this is equal to 1 plus xyz into x square 1, y minus x, y minus x. Here we have y square minus x square. It can be written as y plus x into y minus x, 0, z minus x, z square minus x square. It can be written as z plus x into z minus x, 0. Now this is equal to 1 plus xyz See y minus x here, y minus x here, take it outside, y minus x is outside, remaining is, no, in the third row also, z minus x is common, take it outside, okay, what is remaining? X square 1, y minus x is outside, so remaining is 1, y minus x outside, so y plus x is remaining 0, z minus x is outside, what is remaining here? 1, again z minus x is outside, remaining is z plus x, then here 0. Now, 1 we have, so one operation we can apply here, that is R3 minus R2. Here R3 minus R2 we can apply, or for the third row R3 minus R2 also we can apply. Apply one operation here, that is apply the operation for R3, where R3 tends to R3 minus R2. What is outside? 1 plus xyz into y minus x into z minus x into, only R3 changes, first and second row as it is, x square 1, y plus x 0, 1, R3 minus R2, so 1 minus 1 0, then z plus x, R3 minus R2, that is y plus x. What is this equal to? X cancels here, so z minus y, then 0 minus 0, that is 0. Okay, now this is equal to 1 plus xyz into y minus x into z minus x into, take z minus y outside from the third row, take it outside, z minus y into, what is remaining? X square 1, y plus x 0, 0, 1, 0. This is equal to 1 plus xyz, y minus x, z minus x into z minus y into expansion along the third column we can do, along the third column. See, if we are doing along the third column, it is sign is plus minus plus, okay, 1 into expansion along the third column, that is 1 into 1 minus 0, other two values are 0. Now this is equal to 1 plus xyz into y minus x into z minus x into z minus y into 1. Now, what is given in the question? Given that this value is same as delta, okay, throughout, given that delta is equal to 0. What does that mean? This implies that either this is 0 or any one of the values should be 0, because given that delta is 0 in the question itself, given that delta is 0, so this is same as delta, so this value should be 0. Now, if it is 0, either 1 plus xyz is 0, or this term is 0, or this term, or this term. Any one term should be 0. But what is given? Given delta is 0 and also given x, y, z are different. Now, suppose x, y, z are different, y minus x cannot be 0 because they are not same. Z minus x is also cannot be 0 because they are not same, they are different. Z minus y also cannot be 0. If these three values are not 0, this value should be 0. That is our conclusion. So, given delta is equal to 0 and x, y, z are different, so we can say that y minus x cannot be 0, z minus x also cannot be 0, z minus y also not 0. Therefore, first term 1 plus xyz, that should be 0. So we can say that 1 plus xyz are 0. This is important. Next one problem, try yourself. Using properties of determinant, prove that b plus c, a, b, c plus a, b, this is equal to 4abc. Okay, thank you.